You know, whenever you look up at the night sky and see all those stars, have you ever really tried to wrap your head around just how far away they are? It's the kind of question that can kind of break your brain, right? Because let's be honest, the universe operates on a scale our minds just weren't designed for. So let's dive in and see if we can find a way to make it all make sense.
Okay, so let's start with what sounds like a pretty simple question. I'm not even talking about some super distant, exotic star. I mean our next-door neighbor, Proxima Centauri. How far away is it?
In kilometers, it's that. 40 trillion. That's a 4 with 13 zeros behind it. I mean, sure, it's an accurate number, but does it really mean anything to you? Can you feel that distance? Nah, probably not. It's just a big, useless number.
And you know what? There's a perfectly good reason for that. Our brains evolved to figure out the distance to the nearest river, or, how far away that saber-toothed tiger was. Survival never depended on calculating the distance to a star. So these cosmic numbers, they just feel totally abstract, like they're not even real.
So, faced with this problem of these completely incomprehensible numbers, astronomers did something brilliant. They didn't just get bigger calculators. Nope, they completely changed the measuring stick. They came up with the concept that's, it's both a unit of measurement and, honestly, kind of poetic.
And that solution is the light year. Now here's the most important thing to get right, because it trips a lot of people up. Despite having year in its name, a light year is a measure of distance, not time. Say it with me, distance, not time. It's the ultimate cosmic yardstick, and it's based on the fastest thing we know of, light itself.
So how does that work? Well, light is unbelievably fast. It zips along at 300,000 kilometers every single second. In just 1 second, a beam of light could circle the entire Earth more than 7 times. It's just staggering. So if you let that beam of light travel, uninterrupted, for 1 full year, it covers about 9.5 trillion kilometers. And that distance, that is 1 light year.
So you see, a light year isn't just a bigger number. It's really a conceptual bridge. It connects what our little human minds can sort of grasp with a scale that is otherwise totally beyond us. Saying a star is 4 light years away feels manageable. 40 trillion kilometers? That's just static.
All right, so now that we have our awesome new measuring stick, let's actually go on a journey. We're going to start small, right here in our own cosmic neighborhood, our solar system, and then we'll work our way out.
Okay, even staying local is pretty wild. Light takes about 1.3 seconds to get from us to the moon. Not bad. But to get from the sun to us, that's an 8.3-minute journey. And if you wanted to send a message at light speed all the way out to Pluto, you'd be waiting 5.5 hours. We haven't even left our own backyard, and we're already talking in light hours.
Let that sink in for a second. The sunlight that you feel on your face right now actually left the sun more than 8 minutes ago. So if the sun were to just poof, vanish right now, we would keep on orbiting and enjoying a sunny day for a full 8 minutes before we were suddenly plunged into total darkness. It's a truly mind-bending idea, this cosmic speed limit.
Okay, deep breath. We are about to make a huge leap. We're leaving the solar system in the rearview mirror and heading out into the true deeps of interstellar space.
So here's our old friend, Proxima Centauri. Using our new language, it's a very neat and tidy 4.24 light years away. Simple enough. But look at this comparison. If we wanted to send our fastest ever spacecraft to go there, it would take somewhere around 70,000 years to arrive. That really shows you just how incredible the speed of light is.
And this is where it all gets really, really profound. Because light from all these distant things takes so long to get here, looking out into space is exactly the same as looking back in time. It's not a metaphor. Every telescope is literally a time machine.
Let me make this real for you. Let's take Polaris, the North Star. The light you see when you look at it tonight left that star 430 years ago. When that photon started its journey towards your eyeball, Shakespeare was alive, writing plays like Hamlet. You are literally seeing the past. For all we know, Polaris could have blown up 300 years ago, and we'd still be clueless for another 130 years. Wild.
Okay, let's zoom out even more. Our home, the Milky Way galaxy, is about 100,000 light years from end to end. Our closest big galactic neighbor, Andromeda, is 2.5 million light years away. And that's our neighbor. The Virgo cluster, a massive group of galaxies, is over 50 million light years away. The numbers just get astronomical.
Let's just hang on Andromeda for a second. That fuzzy little patch you can see in a really dark sky, that's light that began its journey 2.5 million years ago. When that light left, our species, Homo sapiens, didn't even exist. Our ancient ancestors were just figuring out how to walk on two legs. We are looking at a truly ancient past.
So, this journey outward, it naturally leads to the biggest question of all. If we just keep zooming out, where does it end? How big is the piece of the universe that we can actually see?
The answer is 93 billion light-years. That's the diameter of the observable universe. It's a sphere of space and time so ridiculously huge that our entire Milky Way galaxy is less than a single grain of sand inside it.
Okay, hang on. Wait a minute. Your brain should be setting off some alarm bells right now. If the universe is only 13.8 billion years old, how on earth can we see something that's 46.5 billion light-years away in any direction? How can it be 93 billion light-years across? It sounds like the math doesn't work. It seems like a paradox.
Well, the answer is maybe the single most mind-blowing discovery in all of science. The universe is expanding. The very fabric of space itself has been stretching out the whole time that light has been traveling towards us. So the object that sent that ancient light is now way, way farther away than it was when the light started its journey all those billions of years ago.
So, after taking this absolutely incredible journey across billions and billions of light years, it feels only right to bring it all back home. What does this immense, incredible vastness mean for us, right here, right now?
I don't think anyone has ever put it more beautifully than Carl Sagan did when he was talking about that famous pale blue dot photo. We live on a tiny speck, a mote of dust suspended in this immeasurably vast cosmic ocean. And that feeling it's both humbling and completely awe-inspiring.
And hey, remember how we started this whole thing, talking about how our brains just aren't built for this kind of scale? Well, that's true, but that's not a failure. If anything, it shows the unbelievable power of our intellect. We have created tools like math and concepts like the light year that let our minds travel to places our bodies could never, ever reach.
We might never physically cross the enormous voids between the stars, but that has never ever stopped us from exploring, has it? We do it with our telescopes, with our math, and most of all, with our imagination. So maybe the most remarkable journey isn't the one across all those light years of space, but the one we take right here in our own minds. The journey from not knowing to understanding.